Hello everyone, welcome to the live class. So guys, today we are going to have another very important session in which we will be discussing some more important questions and very important concepts of mathematical physics. So I hope you all are ready for the further discussion, and just in some time we will be starting the discussion. Before that, I need to show you some of the important slides now, and even I'm gonna let you know about the latest offer which is going on Unacademy, and that is just valid for today. So if you don't want to miss it, or any of your friends are there, those who don't want to miss this offer, they want to grab it, you can let them know about the offer too, because this is just valid for today. So just few hours are remaining when the offer will be ending. So guys, anytime whenever anybody will be proceeding further to take the subscription, they can use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. And by using and by applying this referral code, you will be able to get the discount in the total subscription amount. And this is just for 6 month subscription. You will be able to save 20% if you will use and apply the referral code. Okay, and even in upcoming days, so many new courses by the top educators will be starting, new batches will be starting. So if you want to do the best preparation with these batch courses, with these new courses and the classes, and you don't want to miss them, even now the notes are available on the learning app. So if you want to check out all these important things and want to take your preparation to the next level, you can take the subscription today, and don't miss this offer too. Now let's continue the discussion. Few more points I'll be discussing here, and after that we are just going to continue the further discussion part. Okay, we will start taking the questions and concepts along with the tricks. Next thing here is the difference between the plus iconic and the light subscription. It has been shown here on the screen, guys. What are the benefits you will get if you will be taking the plus subscription, or you will be taking the iconic subscription? Okay, all that has been shown even along with the light subscription. One more thing, even now the notes are available on the learning app. So anytime whenever anybody will be taking the subscription, okay, whether plus, iconic or light, so you can clearly get an idea that what are the benefits you will be getting and how it will be helping you to take your preparation to a very good level. So that's how everything will be helping you this way. Now a few more slides I'll be showing you, and after that we are going to continue the discussion. This is regarding the light subscription, this is regarding the plus subscription. Even when anybody will be taking the light subscription, they can use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. And next is iconic subscription. As anybody will be taking this subscription, what are the benefits they will get and how it will be helping them, like all that has been mentioned here, okay, even in this case. And next is the referral code part, all that even clearly mentioned here. Latest offer I have already shown you. You can save 20% if you will take the subscription today, and you just have to use and apply the referral code, that's Anjali A Live, to grab the offer. Now next thing is, this is about the community feature we are going to have on Unacademy, which will be helping you to get the latest updates, new courses updates, and many important things you will get to know in the community feature, or the tab which is there in Unacademy learning app. This is something about me. This is going to be about the session, and this is going to be about the Unacademy learning app. Now let's proceed further and let's continue the discussion. Let me just tell you about some important concepts, and let's take some questions, tricks, and all these important things here. If in case anywhere there will be anybody having any doubt and you want to ask something, you can let me know about it. We will be taking those points even here. So right now what we will be doing, we will take the question, and whatever concept will be involved in the question, I'll be helping you to like get it clearly. I'll be explaining it too. So this is how everything will be working. Okay, I hope you all have got it, and if yes, that's great. If no, you can ask the question you will have. So let's take the first question right now, guys. Give me a second, let me just write it here. The question is, consider the following. Ordinary differential equations The one equation which is given is all the different type of questions from different concepts we will be taking. And for your upcoming GATE exam and CSIR NET exam, it will be helpful, guys. With the boundary conditions, x at t is equal to 0 is equal to 0, and x at t is equal to 1 is equal to 1. The value of xt at t is equal to 2 is, options are root e minus 1, root e square plus 1, root e plus 1, and root e square minus 1. Try it now, guys. As anybody will be getting the right answer, they can mention it in the comments that what is the right answer according to them. And if you will not be getting it, don't worry, because I'll be explaining each and everything step by step. Or if something is not clear your side, let me know. Very good evening, MD. It's okay, MD. If something is not clear or something you have missed, let me know. So it is mentioned as xt at t is equal to 2 is. Okay, that part I have just mentioned here. Guys, start working on it. And you know, at this point of time, the practice is going to be important for everyone. Reason, your exam is just few days away. Okay, if you are preparing for GATE or any other similar exams too. The other thing, even if you're doing the preparation for CSIR NET, you need to practice. Okay, because when you work on the questions, you get to know that okay, this is the weak point for me, this is where I can make mistake and all. So you get to know that they are at that point you have to be extra careful. So it's important. Do it now, giving you some time, as you will be getting the answer mentioned done or mention the right option in the comments. Or in some time I will be starting the discussion too. Excuse me. If you want me to start the discussion, you can even mention that. I'll be starting the discussion then. Nobody has mentioned the answer till now. If you are solving it, guys, as you will be getting the answer, mention it, or just in some time now I'm gonna start the discussion too. Okay, I think we should start the discussion as well. First of all, we need to check the type of differential equation. So for example, it's a second order differential equation, okay, second order. But in the second order, when we do the preparation of the differential equation topic, in the second order, we mainly consider the two different type of equations. One is homogeneous, another one is non-homogeneous one. When I talk about the homogeneous, the standard form of the equation is d2y by dx square plus px into y is equal to q, okay, and not px, just p I'll be writing here, or we can even take px equal into y is equal to q. Just a second, this is going to be the mix and match. Once again, let me just write it. Okay, plus qy equal to 0. Now again, I've just mixed the linear differential equation part. Let me just write it again. d2y by dx square plus p dy by dx plus qy equal to 0. This is the correct form of the homogeneous second order differential equation. Even included, or we have just written the form of the linear along with the second order. That is not the exact form. This is the exact form of the homogeneous second order linear means order 1, okay, second order and degree 1, because the overall power of this term is 1. Done. A linear differential equation. Now if I'm going to talk about the next thing, that's going to be, there is non-homogeneous too. What will happen in case of non-homogeneous? That's going to give you the right hand side non-zero, which means it can be some function of x, it can be some constant, anything can be there, okay, as per the form mentioned. So the point is, our equation which we are having, is it matching with any of these forms or not? Also one more thing here, p and q must be constants. They cannot be the functions of x, they will be just constants. In the first order differential equation, that is the linear differential equation, p and q can either be the function of x or can be the constants, but here they can just be the constants, okay, they are not supposed to be the functions of x. Now in this case, what will happen? You can see this form, is it matching with that exactly? The answer is no, it's not matching. Why? You can see the power of this term is 2, it's not as per the form, okay. Other thing, it's a function of x, while I have told you p and q must be the constants, it's not as per the form. Other thing, if you will even see the format here, it's not exactly matching with the format given to you there, which means that you got to know it's not going to be exactly the second order homogeneous differential equation. Done. So what it will be? Now for such type of equations, we try to simplify or just try to modify their forms. But how it can be done? Let's consider it. It's going to be x d2y by dx square. Okay, I have taken this x common, or you can say taking LCM for it, like that. Anyway, just you are going to simplify this part, dt square minus x dx by dt, and that is equal to what? 0. This is what you will have. Now you will see that here we are gonna stuck once again. If somebody has not worked on this question earlier, they will think like, what next? Okay, just trying to simplify. So these terms which you are getting now, like this one, you can differentiate this term, that is d by dt of x dx by dt. Then what will happen? You will be using the product rule here. First term as it is, second term differentiation, or it is dt. Second term differentiation. So it will give you the first term, same first term. When I am taking the differentiation of this part, first term as it is, second term differentiation. Guys, x. Now next thing is plus second term as it is, first term differentiation. So that's giving you dx by dt whole square. So what I am showing you is something, I can write this equation in a way that is d by dt of x dx by dt minus x dx by dt, that is equal to 0. How I'm writing it this way? Because when I'm differentiating it now, I'm getting the first two similar terms, exactly same terms. Okay, so what I've done, I have differentiated it and written it at the places of these two terms. Minus of this is already there. This is what I've got. Now next, now again we want to simplify it a little more. So don't just consider that you have to get the answer. Also consider what steps you are going to take, how you are simplifying, how you are thinking, how you are considering all these things. So focus on that part more. Maybe you will not get the same question again, but you can get some similar, some other related questions too. So in the exam, you have to decide it. And when you are going to focus on this part, that how the things are going to work, how you are taking the steps and all, so it will be helping you this way. X dx by dt equal to what? Let's say P, okay, or Q, or like whatever is not there in the question, you can take that. Now you can write it as dp upon dt minus P, that is equal to 0. Now let's consider the next thing, that is dp upon P equal to dt. Now what is this? This is going to be a normal first order differential equation, okay? So dp upon P, integrate, that is log P equal to T plus C. But C I will take as log C. Reason behind it, whenever log is present in the question, now we prefer to write, whenever log is present in the question, we prefer to write the what? Just a second guys. We prefer to write the constant as a log 2. Okay, so whenever we are going to have, just a second, okay, so we prefer to write the constant as the log. Done. So in this case, what will happen? Just a second. Just a second. Okay, so constant as a log we will be considering. Done. Next is log P is minus log C. And now there can be one question you can have, that is it necessary to consider the log on the other hand too? So the answer is not necessary, but automatically, even if you will just be considering it to be a normal constant. Very good evening, Anuradha. So what will happen? You will be able to consider that further when you find or try to find the constant value, automatically it gives you the log. So there is no issue even if you are considering just a constant, okay, and you are just going to get the answer this way. So your answer will be remaining same, no issues. Take either C or log C, but it that you can. Anuradha will be informing you about it. While for tomorrow chances are less, Anuradha. Very good evening, Ankit. Done. So chances are less for tomorrow's special sessions, but whenever it will be, like I inform you about the other sessions I've informed you earlier, we'll be trying to inform you for that too. Done. So I have made it clear, while the log C, when you take as a constant, it makes the calculation easy, it makes the process easy. Done. So in this case, what will happen? Log P upon C, that is log M minus log N, is equal to log M upon N, that is equal to T, and P upon C is equal to e to the power T. Done. So here you will be able to consider it, P is equal to C e to the power T. This is you got, because our equation was in terms of P, so that's how we got it. Clear? Now next thing, once you got the P value, what is P here? X dx by dt, X dx by dt. Let's put it back, the value of P here, X dx by dt is equal to C e to the power T. Done. Now let's consider the next thing here, that's C e to the power T and dt. Integrate, next x square upon 2 equal to C e to the power T plus D, just normally integrated. Next is, if we are going to consider the next part, that is a boundary condition, T is equal to 0 will give you x as well 0. So put t is equal to 0 and also consider x equal to 0 corresponding to that. It's going to give you c plus d is equal to 0 and c is equal to what? Minus d you will have. Done. Next thing. If we will consider the next part here, that's going to be t is equal to 1 will give you x is equal to 1. So let's consider that next boundary condition in it. T is equal to 1 is giving us x is equal to 1 as well. Done. So in this case, what's going to happen? 1 upon 2 is equal to CE plus D. Just check it out. And from here you got C is equal to minus D or D is equal to minus C. Anything you can write. So half equal to CE minus C. Let's say I'm writing. For D is equal to minus C as well. So 1 upon 2 E minus 1 equal to C. This is how you will consider it. Done. Next thing, 1 upon 2 E minus 1 equal to C. C value you got, what will be the D value this way? The D value will be minus sign of it. So that's going to be simply D is equal to minus 1 upon 2 E minus 1. This is what we will have. Okay, just till this point, if anybody is going to have any doubt, mention it. Otherwise, have a look at this. Done. Next, if I'm going to talk about the next thing here, that's going to be let's consider it. D you got, C you got, just put them here in the final expression you were having, this one. Okay, the constant values. So x square upon 2 equal to C is what? 1 upon 2 E minus 1. E to the power t plus d. D is what? That's going to be minus 1 upon 2 E minus, oh, it should be in the denominator, not in the numerator. E minus 1. Done. Let's simplify it. You have to consider or find the value of x at t is equal to 2. So let's put t is equal to 2. X is equal to what? When t is equal to 2 you are going to have. So just put the t value to done. E square minus 1 can be taken as a square minus b square. You can even write it as e minus 1 into e plus 1 upon 2 e minus 1. 2 and 2 even you can simplify. Okay, whether just simplify it with this part. X square is equal to e plus 1 you are getting. So x is equal to square root e plus 1 you will have. This is what you are going to get. And what is the right answer? That's going to be option C, which is the correct one. Now tell me the whole process is clear to everyone or not, or is there something not clear, somewhere there is any doubt? Just mention it. You can see like complete process, all the steps whatever are there. I'll just try to make them clear to everyone, but if you are not getting it, let me know. One single question, but so many ideas you can get. The first one, let's analyze it. That is, the form is not matching with the exact form of the differential equations we have studied or we prepare generally. We modify that form and try to make it the simple form. Okay, the modification is possible there. Done. And how it has been modified, we have observed it. Second thing, even after modification didn't get the exactly similar kind of expressions, then try to consider some value equal to something, third parameter, and then we had the simplified form of the equation. So this can be done. Okay, this is something you got to know. And rest of the calculation steps in the process, the log as a constant you have to take. Okay, like all that even we have talked about. So I hope each and everything is clear to everyone, but in case if there is any question, query or doubt you will have, mention it. I'll be considering that part. And if everything is clear, I'm going to give you the next question too. You can just mention it if something is not clear or somewhere there is any doubt. Or otherwise, I'm going to give you the next question, guys. Very important thing you will get to know with this question too. Okay. The first one we have taken was from differential equation. The next question we are taking is from contour integration. Both are very much important topics for NET, as well as very much important for your GATE exam. Okay, so focus on both the topics very well. The integration over gamma z e to the power iota pi z upon 2 upon z square minus 1 and dz along the closed contour gamma shown in the figure is done. Next thing, options. Try it now and let me know as you will get it done. And if in case there will be any doubt or difficulty, you can tell me. By looking at the question, you will find like it's easy, it's simple, you can do it. But when you will try, you will get to know where you are making mistake or where there are chances of making mistake from your side. So it's important to solve it. Do it now. And as anybody will be getting the answer, mention it in the comments. Excuse me. Try. And whatever is the right answer according to you, you can mention it in the comments. Giving you some time, and after that I'll be starting the discussion too. Nobody has mentioned the right answer till now. Waiting for your reply. Nobody has mentioned the answer yet. Very good, Anuradha. But I'll be discussing it whether it is the right answer or not. So together we'll be solving it to finalize the final or the correct answer. Well, it can also be the one, but still, let's solve it together. And if in case there will be any mistake you have made or something you need to change, you will get to know about it soon. So let's start the discussion too. Step number one, let's find the pole. So for finding the pole, we know what is the pole exactly. That is the finite value, like it is dz, integration for z is there. So finite value of z which can make this function infinity or not defined. So when I'm going to consider it, the denominator I have to equate with 0, and that will be giving me z is equal to plus minus 1. Okay, why I have equated the denominator with 0? Because we know that any fraction where we are having the denominator as a 0, that is infinity or not defined. Okay, so that's how we get it. Now next thing, if we are going to consider the next thing here, that's going to be we have to check the order of the pole, and we also have to check this part whether these poles are lying within the contour or not. So we can say both plus 1 and minus 1 are within the contour. So this is how it's going to work, and this is how it will be giving you the idea about finding the residue, because you can proceed further now. And the order of the pole also you checked, it's 1, the overall power of the term or the expression you got the pole from. Now next thing, let's proceed further. It's going to be limit z tends to 1, z minus 1, fz, that's going to be z e to the power iota pi z upon 2 upon z minus 1 and z plus 1. Now just simplify this part. Which formula I have used? That is the first order pole, the first order pole or simple pole associated formula to find the residue. That is limit z tends to a is the pole there, z minus a and fz. This formula I have used. Okay, a is the pole, that is 1 in my case, like here. So z minus 1. Fz is the exact expression I have written. Z square minus 1 has been taken as z minus 1 into z plus 1. Apply the limits. Z is equal to 1 you have to put. It will give you e to the power iota pi by 2 in the numerator, which is cos pi by 2 plus iota sin pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1. So iota upon 2. This is what you are getting for plus 1 as a pole. While for minus 1, if you will check it out, what you will get, let's have a look at that. Limit z tends to minus 1, z plus 1, fz, that's going to be z e to the power iota pi z upon 2 divided by z minus 1 into z plus 1. Simplify, same formula I've used which I've told you, this one. Okay, simple pole associated formula to find the residue. Now next, you will be applying the limit minus 1 e to the power minus iota pi by 2 upon z minus 1, that's minus 2. After applying the limit, minus minus plus cos minus pi by 2 plus iota sin minus pi by 2, that is minus iota we will have here, upon 2. Okay, because minus minus simplified, and the one more negative we will get from the exponential part. Next thing is, we are just going to use the formula for the integration, that is 2 pi iota into sum of residue. Here is the main point. It is anti-clockwise direction, but if I will take the arrow ahead, I'm gonna get the clockwise direction. Clockwise means minus 2 pi iota into sum of residue for this pole, and this will be 2 pi iota into sum of residue for this pole. So for this one we got iota by 2, for this one we got minus iota by 2. Minus iota by 2, iota square minus 1, minus minus plus, so minus 2 pi from here and upon 2. Okay, and from here minus 2 pi upon 2, which is minus pi. Okay, minus pi. Hence, you are going to get it to be minus 2 pi as your final answer. Anuradha, look at this. Z is there. You will apply the limit. So minus 1 is minus 2. This is how you're just getting it. So 2 in the denominator, this way you will have. Are you asking for the same 2 or some other? Anuradha, is it clear now? Done? If there is any other doubt, let me know. Done? Okay, that's great. Even guys, if anybody is gonna have any doubt, let me know about it. We will talk about that. And if everything is clear, that's great, great, great. Tell me, tell me, tell me. Everybody has got it now. That means we can proceed further to do more discussion and to take more important topic. Now you can see where was the twist in the question, just in the figure part, and how we are going to have the arrows direction one side and the other. So that's making everything different. Next question from the next topic, that is complex analysis part. Maybe Anuradha, ho sakta hai? Because when I am getting them, I am replying to you. So like if you are doing some comment before or earlier and I am replying you late, just when I am replying you, उसी टाइम पे कमेंट आ रहे हैं, तो आप देख सकते हैं कि टाइम लग रहा है कि सेम टाइम पे ही आ जा रहा है. Done? Okay, let's have a look at the next question, guys. It's from complex analysis part. Again, important for both the exams and other similar exams too. Try it now and let me know as you will get it done. Okay, Anuradha. No, Anuradha, because direction sign is also there. Clockwise negative. So you are not just adding plus I by 2 and minus I by 2. This is negative. And this is going to have the minus 1. Its residue is also minus iota by 2. So minus minus will make it positive. The other one is here. Okay, iota by 2. So this will be positive. So both are going to be positive because this negative sign is making a difference. Like it is making it overall positive value, not negative. Did you get it now? Direction. Yeah. This is the next question, guys. As anybody will be getting the answer, mention it in the comments. What is the right answer according to you? Most welcome, Anuradha. Excuse me. As anybody is getting the answer, mention what is the right option according to you. And you can see each and every question is going to have something in it which can help you to work on your concepts, to know about it, where there are chances of making mistake in the related question and the concept. So this is how everything will be something which will help you when you are working on these questions. Mention as you will get the answer. Waiting for your reply, guys. Nobody has mentioned the right answer till now, whatever they have got. So I'm gonna start the discussion in just some time now. Or I think if you are sending some comments and I'm getting them late, so that can be the reason too, because I'm not able to see anybody's comment till now, like regarding this question's answer. Okay guys, let's talk about it. U as a real part of the function fz is equal to u plus iota v of the complex variable z is equal to x plus iota y, where a comma b are real constants and a is non-zero. Okay, the function fz is complex analytic everywhere in the complex plane if and only if this is analytic everywhere. Okay, now what do you know about the analytic function? There are few things you can consider, but what are these things? The first thing is Cauchy-Riemann equation, that if there is any function which is analytic, it will satisfy the Cauchy-Riemann equations, and there are two equations we are having, u, v, x, y. This is just a way I have taken or just written it in this manner so that you will get to know the trick. U, v, x, y, same sequence, it's positive. U, v, y, x negative. Okay, delta u upon delta y is equal to minus delta v upon delta x. So this is going to be negative. Now these are the two Cauchy-Riemann equations, but we are not having u and v both given, so we can't consider this part. Okay. The another thing is, whenever you are going to have the real part or the imaginary part of any complex analytic function given to you, in that case you should know that it's going to be satisfying the harmonic functions condition, or known as Laplace equation. Done. Similar to the EMT part, we are going to have delta square v is equal to 0. So real and imaginary parts both satisfy the harmonic function condition. Delta to u upon delta x square plus delta to u upon delta y square equal to 0. Delta to u upon v is the imaginary part, u is the real part, whatever, but both are going to satisfy the conditions. Okay, and this is how you can write them. That is also equal to 0. Now if I'm going to talk about the next thing here, what is that? That's going to be you are having the real part of the function given to you. Just put the value of u here, that, and see what it will give you. So when you are differentiating with respect to x twice, it's going to give you very good, Anuradha. That's great. Yeah, right answer, Anuradha. So it's going to give you a square, same as the u value given to you, other than that, plus cos minus then plus sine, so minus b square, and same as u given to you as a function of x and y, as a function of x and y, that is equal to 0. So from here you will get b is equal to plus minus a, or a is equal to plus minus b. That's option B, which is the correct answer. So the only concept we have used here is what? That's going to be, you are going to have the like harmonic function condition, which is helping you to get the answer, because you just had the real part given to you. You didn't have the imaginary part, so that's how you'll be proceeding further. I hope it is clear now to everyone, and if yes, that's great. If no, let me know, and we are going to take the next question if everything is clear. Just a second. Next question is here. Also guys, as I have told you about the latest offer, and this offer is just valid for today. So if in case there is anybody who wants to like grab this offer and don't want to miss it out, even your friends or anybody, you can let them know about it. They can take the subscription today, and they can grab this offer. They will save 20% on 6-month subscription by using and by applying the referral code. That's Anjali A Live, as mentioned here on the screen. So by using and by applying this code, they will be able to get the discount in the total subscription amount. Okay, so that's how it's gonna work, but it is just valid for today. So if anybody will be proceeding further to take the subscription today, they will be able to grab this offer. And rather, two more questions. Let's take two more questions. The function z upon sine pi z square of a complex variable z has and poles of order 2 Try it now and let me know as you will get it done, or whatever is the right answer according to you. Mention it, mention it, mention it. Whatever is the right answer according to you, you can just write it in the comments, or I will be discussing it if anybody will not be getting the right answer. If you want to practice more and more questions, like even more than 2 after this, we can take them as well. So it's up to you. If you want me to take more questions, more discussion, we can do that too. But if you want me to just consider this much, we can think about it as well, because we are going to have approximately 1 hour right now. So if you want me to take more questions, I'll be taking that as well. The function z upon sine pi z square of a complex variable z has a simple pole at 0 and poles of order 2 at plus minus root n for n is equal to 1, 2, 3 and so on to a simple pole at 0 and poles of order 2 at plus minus root n and plus minus iota root n for n is equal to 1, 2, 3 and so on to poles of order 2 at plus minus root n is equal to 0, 1, 2, 3 and so on to poles of order 2 at plus minus n where n is equal to 0, 1, 2 and so on to. Very good, Sarat, but we'll be confirming it whether it's the right answer or some other. We'll be discussing it together. Right now we will just start the discussion, but that's good that you have tried. Even if anybody else will be getting the answer, guys, just mention it in the comments. Waiting for more reply, then I'll be starting the discussion. And guys, in upcoming days, so many new courses by the top educators will be starting on Unacademy. So even if you want to take the subscription, take the subscription today, use and apply the referral code Anjali Live to grab the offer which is there only for today. And new batches, new courses will be starting in just upcoming days. Very good, Sarad. We'll be talking about it. Let's wait for others to reply too. Guys, just one answer till now in the comments. Only Sarath has replied. What about others? What should be the right answer according to you? Okay, I'm gonna start the discussion. What they have asked, the function z upon sine pi z square of a complex variable z has. The pole they are talking about in the comment, in the options given. So we know generally to find the pole we equate the denominator with 0, because we know whenever the denominator will take 0, our function will be giving us the not defined or infinity value, and that is the simplest way of finding the pole. So sine pi z square must be equal to 0, and also we know sine theta, for what value of theta will be 0, that is plus minus n pi. Okay, plus minus n pi, where n can have the different values. But here I will not be taking the n value to be 0. Okay, why I will tell you, or z value to be 0, I will not be considering it here. Reason you will soon get to know. Pi cancelled out, I am getting z is equal to, or z square is equal to plus n and minus n, which will give me z is equal to plus minus root n and plus minus iota root n. This is what order 2 pole we have got, because you can see the power, okay, which is helping you to get the final expression. So they are saying that to order 2 pole for this and for this. So order 2 pole for this and for this. Anywhere else it's present? No. And I have also told you I'm not taking 0 there. So n values is starting from 1. Reason is, when I will write the series expansion of sine, that's pi z square minus pi z square cube and factorial 3 and so on to, I will take the pi z square common. So I will just be getting 1 upon z, and pi is there as well, 1 upon something something something, but that will be 1 minus something now. So which means only if I will put z0 here, then only my function can become infinity or not defined. So for 0, that's going to be order of the pole 1. So a simple pole at 0, simple pole, reason its power is 1, and order 2 poles for this and this. So option B will be the correct answer. Very good, Anuradha. Tell me, is it clear to everyone or not? If in case there is anybody having any doubt, just mention it. We will be talking about that too. But if it is clear, that's great. We can take the next question. If there is something you want to ask, somewhere there is doubt and something is not clear, just mention that. We will be considering it. And if everything is clear, I will be taking the next question now. Done? That's great. Let's take the next one. Now you can see with each and every question how many different things we are getting to know, how they are helping us to work on so many. Sarath, plus minus n pi you got from here, z square term was there. Okay, these two, this is order 2. Okay, these two are for order 2. While when you are considering the sine pi z square series expansion, which is something I've written here, and then I will be showing you clearly, z upon sine pi z square series expansion, that is pi z square minus pi z square whole cube upon factorial 3 and so on to. So I'm taking the pi z square common. I'm getting 1 minus pi z square power 2 upon factorial 3 and so on to. Now if I will put this z0, is it making the overall expression not defined? No, because I will just be getting 1, even if my rest of the terms will be 0 here. I will not be getting 0 overall from this bracket part. But 1z will get simplified from this part. I'm just going to have 1 upon pi z. Now if I will put z0 here, it's making the overall function infinity. So what is the order? Now for z is equal to 0, it's order 1. That's how you are saying order 1 for z0 and order 2 for plus minus root and pi and like and all these two. Did you get it now? So it's all about simplification. When you are just going to observe all the steps of simplification, how you're going to get it, what are the things you can consider, okay? So you will be getting both the things here, the simple pole at 0 and the order 2 pole at plus minus root n and plus minus iota root n. Clear or not, let me know. If in case there is still any doubt, we can talk about it. Second derivative is non-zero. I think you want to say the verification part. So for verification, what you can do, you can just check out the residue at the simple pole. When we are saying na 0, what we can do, we can check out the residue at the simple pole, that is 0 at 0. If residue is giving you some finite value, that means your answer or expression is correct, or the way you have mentioned that it's a simple pole at 0, it's correct. But if it will be giving not defined or something like that, then you can have some doubt that whether it is or not. Done? So you can even check that way and it will be giving you some finite value too, and this will be the correct thing. And even with the process you can observe it that yeah, it's giving you order 1 pole or simple pole at 0. Check the process I have explained here and let me know if there is any confusion at any point or something is not getting clear to you. We can talk about it. ऑर्डर 2 होगा लेकिन प्लस माइनस रूट एन और प्लस माइनस आयोटा रूट एन के लिए, ठीक है, क्योंकि जेड स्क्वायर टर्म वहाँ पे प्रेजेंट है जिसने आपको हेल्प किया टू गेट द फाइनल पोल्स यहाँ से. और ऑर्डर 1 होगा z इज इक्वल टू 0 के लिए, क्योंकि आफ्टर सिंप्लीफिकेशन आप देख रहे हैं कि सिर्फ ये टर्म आपको हेल्प करेगा टू गेट द इन्फिनिटी और नॉट डिफाइंड वैल्यू व्हेन यू पुटिंग z0 एंड इट्स पावर इज 1. सो दिस इज ऑर्डर 1 पोल, ओके, at z0. So दोनों statement कहाँ है? In option B, and that's how your option B will be the correct one. Tell me still if there is any confusion, or otherwise we'll be taking the next question too. Okay, that's great, Sarat. Next question from Matrix, guys. n minus 2 degeneracy n does not have any try it now and let me know as you will get it done. Very good, Sarat. Very good, Anuradha. That's great. Okay, guys. This question statement is simply going to tell you consider an n by n order matrix, that is n should be greater than 1. Okay, in which a I j is the product of the indices I and j. Okay, so in this case, what will happen in general? We show the matrix this way. That is first row, first column. So A11, first row, second column A12, first row, third column A13, second row, first column. Row number we write first. Second row, second column. Second row, third column. Third row, first column. Third row, second column. Third row, third column. This is 3 by 3 order matrix I have taken. Then I will take the product of indices 1 into 1, 1 into 2, 1 into 3. 2 into 1, 2 into 2, 2 into 3. 3 into 1, 3 into 2, 3 into 3. This is what you are getting. Now you can see it's the scalar multiple of particular row and particular column. Both conditions will get satisfied. So when it is so, you know for any such kind of matrix what's going to happen. Its eigenvalues will be equal to what? Okay, trace comma 0 comma 0. Okay, Anuradha, that's trace is what? 9 plus 1 plus 4. That's going to be 14 comma 0 comma 0. Then you can say 0 you got twice. So degeneracy of 0 is what? 2. Why? The 3 minus 1 is 2. Because 3 by 3 order matrix we have taken. So it is n minus 1 is the like degeneracy of the degenerate eigenvalue. And there is only one degenerate eigenvalue. 14 is not degenerate. It's not present again and again. So one non-degenerate eigenvalue and one degenerate eigenvalue with degeneracy n minus 1. If you will see, has one degenerate eigenvalue with degeneracy n minus 1. About the one non-degenerate one, they didn't mention in any option, so our most appropriate answer will be option A, and that's how you're just gonna get it. Tell me if in case there is anybody having any doubt, we can consider it. And if it's clear, I'll be giving you the next question too. A few more we can take right now. Very interesting question, the next one. Let's see how many of you will be able to do it. If in case in the previous question there is any doubt anybody is going to have, just mention it, guys. Oh, that's equal to in between. यहाँ पे equal to cosine, right? Exponential on the other hand and rest on the other hand. As you're going to get the answer, what is the right option according to you, just mention it. If something is not clear, you can even tell me about that. Waiting for your reply, guys, and after that I'll be continuing the discussion too. It's a very good question. And all the questions we are taking in the session are very, very, very much important for NET and GATE and other similar exams too. Nobody has mentioned the answer till now. Nobody is getting it. Mention whatever you are getting. Just some more time and then I'm gonna continue the discussion too. You want to find the h40 value. In your question you are having the notation h and x, which will tell you n is equal to 4 you can take and x is equal to 0 value you can take. Put these values and write the above expressions. You don't need to take summation because you are putting a fixed value of n. You don't want all the values to be there. h40 t to the power, that's t to the power 4 upon factorial 4, that is equal to e to the power minus t square plus 2t into 0. It is going to be just e to the power minus t square because this is 0. Now you can simply write the exponential series expansion, that will be 1 minus t square plus t square to the power 2 upon factorial 2. So t to the power 4 coefficients comparison you can do. It's 1 upon factorial 2 on the other hand, and this side h40 upon factorial 4 is equal to 1 upon factorial 2. h40 is equal to factorial 443, that's 12, and rest upon factorial 2 will get cancelled out. So h40 is option A, which is 12, which is giving you the right answer. Tell me if in case there is anybody having any doubt, we can talk about it. It was also a previous year question from CSIR NET exam, but similar type of questions you can also expect in your GATE exam and other similar exams too, so it was important. If anybody is still having doubt, mention it. I'll be talking about that too. And if it is clear, that's great. One more such type of question. Slide regarding the latest offer, which is just valid for today. Whenever anybody will be proceeding further to take the subscription, use and apply the referral code Anjali Live to grab this offer. Excuse me. P3 minus 1. Try it now. Let me know as you will be getting the answer. What is the right answer according to you? P and X. And rather, any doubt? We'll be considering it to be the last question in this session right now. Very good, Divyansh. That's great. That's correct too. And rather, it's the generating function fxt is equal to summation n is equal to 0 to infinity p n x t to the power n. For the legendary polynomials p and x is fxt is equal to this. The value of p3 minus 1 is. This is the question statement. प्रॉपर्टी भी यूज़ कर सकते हैं डायरेक्ट, बट अगर किसी ने प्रॉपर्टीज़ याद नहीं की हैं या उसको नहीं पता है तो वो क्वेश्चन के स्टेटमेंट से भी आंसर ला सकता है. लाइक एवरीथिंग इज गिवन, सो जिसको प्रॉपर्टी नहीं पता है स्टिल दे कैन सॉल्व दिस क्वेश्चन. सो एफ एक्स टी इज दिस, एफ एक्स टी इज ऑल्सो दिस इफ यू विल रीड द क्वेश्चन स्टेटमेंट. So you can compare the right hand side parts, they will be equal to. And p3 minus 1 we need to find, so n value I'll be taking 3, so I'm going to remove the summation. So p3 minus 1, x is minus 1, t to the power 3 equal to, then x is minus 1, 1 plus 2t plus t square to the power minus half, that is a square plus b square plus 2ab, a square plus b square plus 2ab, that is a plus b whole square, which is 1 plus t whole square, that's minus 1. Write the series expansion for it. 1 minus t plus t square minus t cube plus t to the power 4 and so on to. So minus t cube coefficient on both sides, it's minus 1 here, it's p3 minus 1 is equal to minus 1. That's giving you the right answer, and that's your answer, option D. Do you want to solve more questions? Let me know. Ready for the next one? Or just this much? If you are finding it interesting and you just want to keep on solving more and more, it's your choice. We can consider it accordingly. More or just this much? More? Okay. Any doubt? If yes, just mention it. I'll be considering it too. If no doubt, let's take the next one. As you will be getting the answer, mention it in the comments. What is the right answer according to you? If you don't know about the steps and the approach, I'll be explaining it. That's great, Anuradha. Few more we'll be taking then. Try. Excuse me. Not in this case, not in this case, not in this case. Reason I will tell you soon. So that's going to be whenever the x term which is multiplied, its power and the order of the differential term, like the second order. So if these are same, here it's 1, here it's 1. If these are same, here the derivative term power is like not present, like order of the derivative term is not present, and the x power is not present too. So if this is the case, such type of equations are known as Cauchy-Euler differential equation. Okay, Cauchy-Euler. So it is a standard form of the equation. Yes, we don't prepare all the standard forms because there will be so many, then you can even get 50, 100, like so many different forms. And it's something we don't consider. But Cauchy-Euler differential equation is one of the equations from the standard case, which is expected, which is important, and which is there in your standard reference books too. Okay, like as a separate chapter as well. So in that case, it becomes important for you to know at least for this case. Now, what are the steps you need to take? See, there is dy by dx, okay, form present. So here what you know y is a function of x. Y is what? It's a function of x. And what we do in this case, we will be considering that auxiliary equation which you will get in general. Okay, it will be the solution of y in terms of x. Done? In general. So what we do, we consider the x to be the function of some other variable. So you will consider x is equal to e to the power z. Z is some third variable. Okay. Now what will happen in this case? Not x, just you are going to consider the dy by dx, x dy by dx. That will be capital D into y. And what is capital D here? That is d by dz. And from where you introduced z, you have assumed the x to be the function of z, that is e to the power z. So that's how you are getting all the steps. Now it's simplified form we will be writing, but before that, these are common steps you follow and you will be following in any such case. For this x square d to y by dx square, it will be d into d minus 1 by. Done. So when you are just going to put the values, let's say your expression will become d into d minus 1 y plus 5 dy, and next is going to be plus 3y equal to 0. Now when you will simplify it, d square minus d plus 5d plus 3, I'm not taking y now, I'm just taking it common and removed it. Okay, d square plus 4d minus plus 3 equal to 0. This is a kind of auxiliary equation, as you simply solve the first or second order homogeneous differential equation. Now, if you want, you can write it this way too, but you have to keep it in mind that d is a function of z. D is simply d by dz. So your expression will be in terms of z, not in terms of any other parameter. And now you have to get the m values from here. So what will be the m values you will have? Let me just check. Is it the same equation you are getting or something else? Check it out. Is it something similar to this you are getting or some other expression you will have? Same? Everybody is getting it same? So 4 can be written as 3 plus 1, 1m. Take m common. Take 1 common. Vectors will be m is equal to minus 1 and minus 3. So your solution will be for what? The y is equal to a e to the power m1z, so that is minus z, plus b e to the power m2z, that is minus 3z. Z is what? X is equal to e to the power z, so z is equal to, what you will have? Log x, after removing exponential from other side. A e to the power minus log x plus b e to the power minus 3 log x. Next, a e to the power log x to the power minus 1, okay, plus b e to the power log x to the power minus 3. Those who don't know about it, m log n, this is the property of logarithmic, log n to the power m. So that's why this initial part I have sent on the power side. It's going to be a x inverse plus b x to the power minus 3, okay. So once you have got it, it is a upon x plus b upon x cube. Where it is, it's in option D, and that's your right answer. Please tell me if in case there is anybody having any doubt, we can consider that part then, but if it is clear, that's great. Let me know. Is everything alright and clear to everyone now? So you got the form of the Cauchy's Euler differential equation. Anytime if you have to consider it, you will easily be able to identify that part. And I think you will not have difficulty in considering the steps to solve it too. Done? Similar steps we just follow to get the answer. Even if you have just solved this one single question right now, you can note down its steps very well, that what we were doing, how we were considering. Similar steps you just keep on considering. Even if there will be term x cube d3y upon dx cube, you will be considering it d minus 1 into d minus 2y, okay. That's how you will take it. Now if I'm going to talk about the next thing, just a second. Yep. Let me just give you the another question. If anybody will have doubt, just mention it, guys. I'll be considering it. Try it now and let me know as you will get it done. What is the right answer according to you? Very good, Anuradha. That's great. So how you will be doing it? Basically, the matrix is given. Common eigenvalues of the matrix you can find, that is A minus lambda is equal to 0. You'll be getting lambda is equal to A minus A over that. One eigenvalue is given is this one. Okay, so for e to the power A matrix, you will be having e to the power A, e to the power A, and e to the power minus A. This one is already given. The product of other two will be e to the power 0. That's going to be e to the power 0 is 1, hence you are getting it to be 1. And also one more thing, yeah, that's going to be the product of eigenvalues must be equal to what? The determinant, and determinant will be even helping you to get that. Okay, because one e to the power A is already there, so you will have to divide it by the overall determinant. That's how you will be able to get it. Trace is also e to the power A, that's correct, and that is the sum of eigenvalues. So anyway you can take it. Either determinant we can find. Okay, for e to the power A matrix, then you need that, not just for the A matrix. And then the product of three eigenvalues will be equal to the determinant of that matrix. Now e to the power A is known and you just want the product of other two. So e to the power A you can take in the denominator of the determinant part, the other two product you will be getting this way. This is how it will be working. Next one. You can try this question in the homework now. Let's keep it this much in this session. We'll be doing more discussion in our upcoming classes. And if you want, I can tell you the right answer for this so that you will be able to verify that what is the right answer and are you getting it correct or not. It's option D. Okay, so everybody can try it in the homework now. Let's keep it this much right now in the session. Okay, Anurada. Thank you so much everyone for joining this session. As in the starting of the session, I've shown you these slides regarding the iconic subscription, the plus subscription and the light subscription. Along with that, the difference between the plus iconic and the light subscriptions have been shown here. Even now the notes are available on the learning app, which will be helping you to take your preparation to the next level. And one more thing, since in upcoming days so many new courses by the top educators will be starting on Unacademy. If you don't want to miss these courses and the classes by the top educators, you can take the subscription. And here is the information about the latest offer which is going on and which is just valid for today. So you can use and apply the referral code, that's Anjali A Live, as mentioned here on the screen, and you can grab this offer. So this is how it will be working. Or even if any of your friends were waiting to take the subscription, let them know about the offer too. They will be able to grab it as well. Along with the referral code, you can let them know about it, because to get the discount anybody has to use the referral code. And here the referral code has been mentioned as Anjali A Live, ANJALIALIVE. That's how you have to write it and apply it. Thank you everyone for joining this session and for attending it till